Alright, so here we are again. I have the sequencer board set up, and I got this power supply here at, from 118 volts to 120. Now, the first one, it could go as low as like 118.7 or something like that, and you go below that and it starts getting flaky. And I was only able to set this to 118 yesterday because this is a programmable smart power supply, so it always tries to outsmart you. Well, I finally figured out what buttons I had to push to get the thing to actually give me 120 volts. So, lo and behold, good news and bad news is, if we run that test program that we ran yesterday, well, let's see if it just merrily chugs away here, cycling its brains out. And let's see how well I can show this. Probably can't show it very well on the video. See if I can get it going here again. Well, as you can tell, I'm not very skilled at this video stuff. But there it is, cycling away. It's done 1,000 cycles now without any problems. So after going through all of that torture yesterday, maybe it was just because the voltage was low. And that should be one thing to check, is make sure the voltages are right. Again, the other computer would start acting flaky if you got much below 118.7. So it probably was just that the power supply was, 118 volts, so the flip-flop started being flaky. But anyway, here we can see it's churning away, done 2,500 cycles so far. So this board seems to be working. But I guess the good news is you kind of got to see tracing through the circuits. And so I guess that's really about it. There it is, churning away. You can see the voltages here. Got 120 on that guy, 96.08 on that one, and 5.0 there for that. You can see the currents here, 0.4 amps at 120 volts and 0.33 amps at 96 volts, and a tenth of an amp at 5 volts here is what we have for power. I don't have any current for the filaments, but they're pretty much what the specs say. So it's probably 1.5 amps at the 48. I got 48.7 showing on the voltmeter there. But there it is, cranking away. We'll check the status here again. Churning away, happy as can be. We've got 5,500 cycles. Now, because of the paddles, these IO Warriors are kind of slow. So, it's only going to get, well, here it's getting 40 cycles per second out of them because they're slow, unfortunately. I wish I had faster paddles. But anyway, it cycles them, checks the bits at the end of each cycle to make sure that it's following the random instructions that it's feeding. The test program running on the Raspberry Pi generates random instructions and feeds them to the board. As the sequencer steps through fetch cycle, the Raspberry Pi will generate a random opcode, feed it into the thing, and then see that it steps through the right, of the defer and the execute cycles, and generates the appropriate, control signals. Oh, the ALU should be adding this cycle, and the accumulator should be loaded at the end of the cycle, or the program counter should be incremented at the end of this cycle, that sort of thing. So the Raspberry Pi checks all those control signals by reading the paddles at the end of the cycle. So that's what it's doing now, and it's gone through 8,700 cycles now and hasn't burped. So you have to make sure the voltages are set right, and that's sort of a hard lesson I learned on the other one, and just kind of forgot this one. Didn't think it would make that much of a difference, but yeah, you have to have the voltages right. Now the minus supply on the other one, I turned down to 87, and it actually ran faster that way. I can just crank this down, and if it barfs, it barfs. Who cares? Turn this down to 87, 84 is still running, 88, 89. Yeah, it's happy as can be. Eventually you turn it down, it's going to get so low it's going to puke, but I got it all the way down to 80 and it's still running. Yeah, that 96 is what I originally designed it for. And the reason being 96, well, the numbers worked out with the resistors, but 48 volt power supplies are cheap. So two 48 volt power supplies gives you 96, and the 120, two 48s and a 24 gives you 120 volts. But I ended up using adjustable power supplies for the thing after all, so that didn't really matter. But that's what I designed the voltages for originally, and those voltage dividers. There's 120 volts for the positive supply and 96 for the minus. But anyway, there it goes. 12,800 cycles without without barfing yet. So there you go. I guess this is a short video. So like I said, good news and bad news on this one.